Chinese-Vicuna is an innovative open-source language model designed specifically to enhance instruction-following capabilities for the Chinese language. It's built by fine-tuning Meta's Llama architecture using a technique called Low-Rank Adaptation, or LoRA, which makes it highly efficient for environments with limited resources. This means it can run on everyday consumer-grade GPUs, like an RTX 2080 Ti, without needing expensive hardware, making it accessible for researchers and developers worldwide. At its core, Chinese-Vicuna addresses a major gap in the field of large language models. While models like GPT-3.5 have revolutionized natural language processing with their conversational prowess, they've been predominantly English-focused. This has left languages like Chinese underserved, with few models that are both effective and practical to deploy. The team behind Chinese-Vicuna, including Chenghao Fan, Junyi Liu, Jia Tian, and the broader Chinese-Vicuna team, recognized this issue and created a model that's tailored for Chinese tasks, such as translation, code generation, and specialized question answering in areas like healthcare and the law. The model leverages hybrid datasets, combining sources like BELLE and Guanaco, which provide a mix of general and domain-specific data. To keep things resource-efficient, they incorporated 4-bit quantization through a method called QLoRA. This reduces the model's size and computational demands while maintaining strong performance. For instance, you can fine-tune a 7 billion or 13 billion parameter model in just about 30 hours on a standard GPU, which is a game-changer for those without access to high-end servers. In terms of performance, evaluations show that Chinese-Vicuna holds its own in various tasks. It excels in medical diagnostics, where it can handle queries with coherence and accuracy, and in legal analysis, providing real-time updates and insights. It also supports multi-turn dialogues, meaning it can maintain context over a conversation, which is crucial for natural interactions. The project's open-source nature, with repositories on GitHub and Hugging Face, includes tools for model conversion, CPU-based inference, and even interfaces for multi-turn chats, making it easy for others to build upon. Diving deeper, the inspiration for Chinese-Vicuna comes from the broader evolution of language models. The release of Llama by Meta opened up new possibilities for the community, as researchers began using it as a base to create specialized versions. Early efforts involved generating responses with models like GPT-3.5 and then fine-tuning other bases, such as Alpaca, to improve efficiency. However, these approaches often required massive datasets and powerful hardware, which isn't feasible everywhere. Chinese-Vicuna stands out by focusing on parameter efficiency. Unlike models like ChatGLM6B, which demand enterprise-level GPUs, or Chinese Llama Alpaca, which increases costs through expanded vocabularies, Chinese-Vicuna uses LoRA to adapt the Llama model with minimal changes. This allows for quick customization in specific domains, such as healthcare for diagnosing symptoms or law for analyzing cases, without retraining the entire model from scratch. When it comes to related work, many existing Chinese language models fall short in two key areas: resource intensity and domain generalization. For example, projects like BELLE provide broad instruction tuning but don't delve deeply into specialized fields. Chinese-Vicuna builds on ideas from multilingual models like Guanaco but shifts the focus to Chinese-centric datasets and modular plugins, making it more adaptable and practical. In their methodology, the team first gathered a wide range of Chinese-related corpora, including general instructions, dialogue examples, and targeted data from fields like medicine and law. They then applied a combination of quantization, either 8-bit or 4-bit, and LoRA to train the model efficiently. This was done using tools from the Bits and Bytes library, which helps manage memory during training. By mixing these datasets, they fine-tuned both 7 billion and 13 billion parameter versions of the model, creating ones optimized for instruction following and conversational dialogues. One of the standout features is its hardware accessibility. You can run a 7 billion parameter model on a consumer GPU without breaking a sweat, and for larger setups, it supports multi-GPU parallelism. Additionally, 4-bit quantization ensures that even on less powerful devices, like standard CPUs, the model performs well, opening doors for deployment in real-world applications where resources are limited. The model's modular design is another strength. It allows for easy vertical domain adaptation, meaning you can plug in specific datasets for areas like healthcare to fine-tune it further. For instance, in medical tasks, it demonstrates competitive accuracy in benchmarks, helping with symptom analysis or treatment suggestions. In legal contexts, it keeps up with real-time updates, providing coherent responses based on structured data. Overall, Chinese-Vicuna's emphasis on practicality and performance makes it a versatile foundation for Chinese language applications. Its community-driven ecosystem, with contributions from developers, ensures ongoing improvements and accessibility. By balancing cutting-edge techniques with real-world usability, this project not only bridges the gap for Chinese instruction following but also sets a benchmark for efficient language model development in underrepresented languages. This approach could inspire similar efforts for other languages, fostering a more inclusive landscape in artificial intelligence.